Let's start our work. This is second chapter of science, class 9. Class 9, second chapter of science. Is matter around us pure? Is matter around us pure? क्या हमारे आसपास जो मैटर्स पाए जाते हैं क्या वो प्योर हैं या नहीं? देखिए, we want to telling something about in this chapter question answer. Okay, look my dear. This is the question answer. First question is what? First question is what is meant by a substance? Or we can say what do you mean by a substance? Then substance. Everything in this universe is made up of materials, which occupy space and have mass. यानी जिसके पास क्या होना चाहिए? Space and mass होना चाहिए. This is called substance. Have both volume and mass. This material is called substance. Okay, I think you all got my point. What do you mean by substance? Okay, next list the points of difference between homogeneous and heterogeneous mixture. You all know about what is homogeneous and what is heterogeneous. Okay, the composition of homogeneous answer. The composition of homogeneous mixture is uniform throughout, while heterogeneous mixture in non-uniform. Okay, and third one, difference between homogeneous and heterogeneous mixture with examples. So we all know about what is homogeneous and what is heterogeneous, and the example of homogeneous: solution of salt in a water, or we can say solution of sugar in water. Okay, and example of heterogeneous mixture: a mixture of sand and chalk, a mixture of sand and chalk. One example is enough for you. Okay, let's start. Let's start new question. A new question is what? How are salt solution and suspension? How are salt solution and suspension different from each other? यानी किस तरह से ये तीनों एक दूसरे से भिन्न है, किस तरह से तीनों एक तरह से डिफरेंट है. We can say salt means colloids and solutions and suspension. Okay, you all know about what do you mean by colloid. Then see, first serial number is colloid are heterogeneous mixtures. We can say salt. Colloid is just examples of salts. We can say here. Yeah, we can say colloids and salts are same things. Okay, salts, or we can say colloids, are heterogeneous mixture, and solution are homogeneous mixture, and suspension are heterogeneous mixture. Okay, there is nothing more difference between in three things. We can say here heterogeneous mixture. Difference is what? Heterogeneous mixture and homogeneous mixtures, and here heterogeneous mixture. They both are same. We can say salts and suspension are same because they had heterogeneous mixture. Okay, accepted solution is a homogeneous mixture. I think you all know about homogeneous and heterogeneous mixture because we have read about it. What is homogeneous and what is heterogeneous. And the second point, the particles of colloids. The particles of colloid are so small. The particles of colloid are so small that cannot be seen by naked eyes, but can be seen by microscope. Oh, really? This is the best thing in this question. We can say the particles of colloids are so small that we can't see these particles by using our eyes. So we need to some more uh, things that we call it microscope. You all know microscope is a thing that magnify the things. What I say? Magnify the things. Or we can say the size of everything. We can say the size of any tiny particles can magnify by using this things. What we call microscope. Microscope is an invention. Okay, a microscope is using something more in a science. Okay, what I say science, because the tiny particles are not able to seen by our naked eye, so we use microscope. So here the use of microscope is the elements, we can say elements of particles of colloid are able to seen by microscope. Okay, and the second, solution. The particles of solutions are smaller than 1 mm, so they cannot be seen by naked eyes of even microscope. Oh, the particles of solution are not able to see by using microscope. Then we have to use here electron microscope. Electron microscope. Okay, what I say? Electron microscope. Electron microscope is the thing that the elements, or we can say the particles that cannot be seen by microscope. Then we use electron microscope. What is the name of this invention? Electron microscope. Then we can say the particles of solution are seen by using electron microscope. What I say? Electron microscope. Okay. And the suspension, the particles of suspension are can be seen by naked eye. Okay. Now we can say in the suspension. Suspension we can use uh, the as a type of any salt things, solid things that we can say salt and sugar. Uh, this is the solute, and the solvent is the water. Okay, now we can say use what naked eye. Okay, the particles of suspension are seen by naked eye. Okay, and next we have to read more. Okay, listen guys, there is three more difference. Okay, particles of these scattered the beams of light and make its path visible. Okay, the particles of salt, or we can say colloid, are able to scatter the beam of light. Beam of light means the ray of sun. The particles of these scattered what? The ray of light, or we can say the ray of sun. And the particles of these cannot scatter the ray of light. What do you mean by particles? Particles of what? Solution. The particles of solution cannot scatter the ray of light, and the particles of these scatter the beam of light and make it path visible. Okay, they both are same in this point. Okay, and this one is a different. Okay, let's start begin fourth. The solution particles do not settle down when colloids are kept undisturbed, so colloids are stable. Okay, the solid particles do not settle down, then we can say they are not going to stay bottom of this flask, or we can say of this container. Okay, and in this the solid particles do not settle down when solution are kept undisturbed, so the solution are stable. Okay, they both are stable. This is the main thing in this difference. Okay, solids, sorry, salts, and we can say collide, and solution, both are same, because the solution of this uh, stable, okay, and the solid particles settle down when suspension are kept unstable, so the suspension are unstable, okay. What I say, unstable. This is the main difference between these three things, okay. The solid particles can be separated by centrifuge process of separation, okay. Centrifuge means what? Centrifuge, or we can say centrifugation. Centrifugation is the thing that are used by separation of the many things. Then we can take here an example of tea. When we sieve the tea, the some particles of some particles of tea, or we can say the solid particles of tea are remain in the sieve. Okay, the solid particles cannot be separated by filtration. Okay, what I say, filtration. The solid particles can be easily separated by filtration. Okay, there is nothing much difference between in this. Okay, this is the next question. This is related by numerical. Okay, what I say, this is related by something numerical. Okay, to make the question is, to make a saturated sodium solution, 36 gram of sodium chloride is dissolved in 100 gram of water at 293 Kelvin. Find concentration at this temperature. Concentration means the what is the liquid, we can say. Concentration is used in the liquid things, okay. When we use some more solid, then the solution is concentrated, okay. Look, mass of sodium chloride, look there, 36 gram sodium chloride, and dissolved in 100 gram of water. 100 gram of water, mass of water 100 gram, and the mass of sodium chloride 36 gram. These things are given in the question. Yes, the mass of solution of sodium, because here the sodium chloride is dissolved in the 100 grams of water. So what will be happen after dissolved in these two matters, in these two matters, we can see solution, because solution is what, then the solid and the solvent are mixed, then the result of solution, okay. The mass of solution of sodium chloride 100 plus 36. 100 means what? The mass of water, and 36 is the mass of sodium chloride. And then we can add this 136 gram. Okay. The concentration of the solution. This is the formula of concentration of solution. Mass of solid. Mass of solid means 36. 36 sodium chloride. Okay. And the mass of solution. Mass of solution means this is the mass of solution. This is the mass of solution, okay. Then into 100, then this is the divided by 136, and the answer is 26.47%, okay. Yes, we can say that the required concentration of the sodium chloride solution at 293 K equal to 6.47%, okay. Yes, this is the next question, okay. Yes, how will you separate a mixture containing kerosene and the petrol? Difference in these boiling points is more than 25 degrees Celsius, which are measurable with each other, okay. Separation of mixture of kerosene and petrol. To separate the mixtures of kerosene and petrol, we shall use the process of distillation. Which type of process? Distillation, because the difference in their boiling points is more than 25 degrees Celsius, okay. The process, or we can see the procedure. Put the mixture in the distillation flask and fix a thermometer in its mouth, okay. With the help of a cord, arrange the whole apparatus as shown in figure 2.1, okay. Heat the mixture slowly and gradually and carefully observe the readings of the thermometer, because in the thermometer there was a scale. Okay, so we have to observe that scale. Petrol start to evaporate, or we can say boil, and it collect in the receiver after condensation through condenser. Through condenser. Okay, the reading of thermometer remains fixed until and unless the whole of petrol is separated and collected in the receiver. Okay, remove the receiver containing petrol and stop the heating. Kerosene is left in the flask, thus the given mixture is separated. Okay, here we can say in the rural area, we can say, or we can say the village area, most of people using in this method. Okay, uh, to make wine. Okay, here is a wine is a most perfectful example of to understand this method. Okay, because in this method, yeah, by using this method, most of villagers making a lot of wine and sold it in a market. Okay, I think you all know about this method. Okay, yes, this is the figure of this method. Okay, in your book, in your book, 22 page number. Okay, yes, distillation process to separate a mixture of kerosene and petrol. Okay, because petrol needs petrol needs less temperature and kerosene needs more temperature than petrol, and then less less temperature petrol will be aired. Okay, and the kerosene will be remain in the flask. So there is a separation of petrol and kerosene. Okay, yes, I will teach you. Name the technique to separate. Okay, butter from curd. Butter from curd by using centrifugation. Okay, centrifugation. Yes. Salt from seawater. Yes. Crystallization, or we can see evaporation. You all know what do you mean by crystallization and evaporation, and the comfort from salt by using sublimation. Okay. What type of mixtures are separated by the technique of crystallization? The mixture of crystalline and non-crystalline substance. Okay. What is the answer? The answer is the mixture of crystalline and the non-crystalline substance. Okay. Yes. Classify the following as chemical or physical changes. Okay. Cutting of tree, melting of water in a fan, rusting of almirah. What we say it? Almirah. Boiling of water to form steam, passing of electric current through the water and the water breaking down into hydrogen and oxygen. Okay. Dissolving common salt in a water, making a fruit salad with raw fruits, and burning of paper and board. Okay, yes, physical change, cutting of tree. There is no change in their space. Or we can say, what do you mean by physical changes? Physical change means the changes will be the changes one more time will be changed in their real phase. Okay, like we can use here like a water. Okay, we can freeze the water and then we can heat that particular water and we will get what water. Oh, so we can say there is in physical changes there is no change in their physical state. Okay, melting of butter in a pan, boiling of butter of from steam, dissolving common salt in a water, making a fruit salad with raw fruits. Okay, yes, some examples are there. Okay, chemical changes. Chemical changes means the physical state of that particular matters are not able to change again. Okay, Resting of almirah. One time resting is used on the iron, then we will not make them your real metals. Okay. Passing of electric current through water and the water breaking down into hydrogen and oxygen. Okay. And burning of paper and wood. Okay. Yes. Next, which separation technique will you apply? Will you apply for the separation of the following? Okay. Sodium chloride. Sodium chloride by using evaporation. Sodium chloride from its solution in water by using evaporation of by or by crystallization. Okay. And second, ammonium chloride from a mixture containing sodium chloride and ammonium chloride. And C1 is a small piece of metals in the engine oil of a car. Different pigment from an extract of flowers petal, butter from curd, oil from water, tea leaves from tea, iron pins from sand, wheat grains from husk. Okay, fine mud particles suspended in water. Okay, then first one is by using evaporation and or we can say or by using crystallization, and second one is by sublimation. Okay, and third one is by sieving or filtration. Both are same, sieving and filtration. And D1 is by chromatography. Chromatography is a method of separation of many things. Okay, and E1 is by centrifugation. What I say centrifugation, and F1 is by separating funnel. Okay, and G1 is by sieving or filtration. What I say sieving or filtration, and H1 is by magnet. Okay, and I1 is by gravity separation and by filtration through filter paper. Okay. Yes. Next one is write the step you would use for making tea. When we making tea, what was the step when we making tea? Okay. Yes, we have to understand here what is the solution, what is solvent, what is solid, what is dissolved, soluble, insoluble, filtrate, and residue. Residue. Okay. First one is tea required water. Okay, water is a solvent here. In a tea making pot, we can say container and put it on a heater or heat. Okay, you all know about these things. Okay, add required tea leaves which are insoluble in water. Water means solvent. On heating the extract of the tea leaves, making butter colored. By using this tea leaves, butter is colored and add required amount of milk. Milk means here solute and sugar solute, and which is the soluble in water and dissolved in it. The solution of the tea is boiled well. Okay, the solution of tea is boiled well. Filter the mixture. Filter the mixture through a sieve. We get tea drink as filtered. A solution of tea and best tea leaves remains as residue in sieve. Okay. Thus, obtain the tea drink is a solution of sugar, milk, extract of tea leaves in a water. Okay, okay. This one is the next question. Okay, we have to write down this question, and after some time, I will make you understand. Okay, okay. Look dear, this is the important question of your exam purpose. Okay, look dear, look. This question is not able to making you understand. Okay, and after some time I will explain it. Okay. Yes. Next question, explain the following giving example. Saturated solution. What do you mean by saturated solution? Saturated solution, at any particular temperature, a solution that has dissolved as much solute as it capable of dissolving. Okay, as it is capable of dissolving is said to be saturated solution. Okay. I think you got my point. And next, pure substance. The substance which are made of one type of particles. What I say, one type of particles of making substance are called pure substance. Okay, and we can watch the next one. What I say, we can watch the next one. Okay, dear. Examples of copper, gold, carbon, oxygen, ammonium chloride, copper sulfate. Okay, and colloids. The heterogeneous solution in which the particles of solute are so small. In the colloids, the particles of solute are so small that cannot be seen by naked eye but scattered from scattered beam of light, showing Tyndall effect are called colloids. Okay, you all know about Tyndall effect. Okay, example: milk, paneer, jelly, butter, smoke, air. Okay, and next one, suspension. The heterogeneous solution in which the particles of solute can easily be seen by naked eyes are called suspension. Suspension is a simple solution of chalk, muddy water, and so on. Okay, and sixth one, how would you confirm? How would you confirm that a colorless liquid given to you is pure water? Okay, we will find out the boiling point of the given colorless liquids if it is 100 degrees Celsius. Then the given liquid is pure water, otherwise not. Okay, and all this one is the connected question with this chapter, and you all know about all these questions. Question number 7, question number 8, question number 9, or we can say question number 10. Okay, or here is the question number 11 also. 11 also. Okay, now guys, I will tell you. I am uh, I was explained. We can see it was explained in a English language. Okay, if you are not comfortable to me, you have to say to me. Then I am not comfortable by using English only. Okay, then I will translate it very well manners in a Hindi language. So please tell me and reply. Okay, and guys, at the end of this video, I will tell you. Then please support me. Okay, by using subscribe my channel. Okay, and thank you, thank God. Or we can say good night. After watching this video, we can say good night, you all my dear students.